You know, my background is I'm a design engineer. That's kind of what I did my whole career. And in the world I came from, there was a technique that was taught called design for maintainability. So there's different tools that are out there that are trying to accomplish what we're trying to get at today. But I think the reality that we're facing is that we have products that are out there. And those products still need to be maintained. And what we're here in this room for today is to talk about how can we do a better job at that. We've got risks, we identify risks. Okay, how do we mitigate risks? This is a tool, human hazard analysis, that we believe has got some legs in what we're facing into right now. So how can we do better with what we have in front of us today? So if I could start off with George with just the first question. So from Airbus's perspective, you got a mic?
Yes.
So it should be on. What brought Airbus to the conclusion to start HHA when you did?
So at least we have had three good incentives to start to work on the human factor. The first one was the paper issued by HeliOffshore 2.5 years ago, System Reliability Resilience, where Airbus has to propose an answer and so to start to develop a method to answer to this request. The second one was, of course, the accident in Norway, where it leads Airbus to go ahead on safety and to go a step more towards safety. And the last one is that as part of Airbus Group, we have frequent contact with Airbus Fixed Wings, and we have identified that for the fixed wings, they are already working on the human factors. So it makes the decision to Airbus to go on this way.
Thank you. Simon, you were involved with Airbus Fixed Wing, right? Can you speak to that a little bit, your involvement?
Sure. So my role was Human Factors Manager within Airbus Fixed Wing. And we, as we've said, the data is pretty good in Fixed Wing. And we started looking at the accident statistics. And depending on which study you looked at, the maintenance error contribution rate was between 10 and 15%. And also, depending on which model you looked at, it was either the highest cause of fatalities or the second highest cause of fatalities. So that was a major driver for us in Airbus Fixed Wing. The other side was that we had a proposed PNPA to what was JAR 25 at the time. So we suspected regulation was coming to strong drivers to get working on this. So we started looking around to see what methods are available, what we could actually do, what we could take from other industries to actually do this. And for those of you from a military background will be familiar with HAZOP. That was one particular technique we looked at in some detail. Now, HAZOP is very good, but it's very structured, very systematic, and it's based on the process industry. So a lot of it is based on the guide words, and the facilitation is based on process industry. And it also requires you to bring quite a wide group of people together in one room for an extended period of time to focus on a particular part of the system. There was also research from the CAA, from Hazel and her team, who'd done research into this and suggested looking at the existing safety process within aircraft design, using fault trees and failure mode and effect analysis and so on. And we looked at probably about another 10 techniques that could inform us. But we realized we needed to understand what needed to be done, set a set of requirements, and knew that we needed it to be practical. We needed this to be low resource demand, and we needed it to be focused. We didn't want a whole group of people in a room for a week. What we wanted to do was we wanted to actually break this down and allow them to be split up. So we looked at different ways that we could do it, and different ways that we could actually focus using the existing safety process. And we came up with a technique, and we tried it. We tried it on A380. We worked with our suppliers. We worked with some operators and did some research with the CAA to actually refine the model. And then we documented it. We got some training built, and then we deployed it on A400M, A350.
All right, so the work you guys have done today, how's it going to be different, or how would it be used differently in the rotor ring world?
I think the major difference is actually taking it a stage further. This is going beyond what we did in fixed wing, because we're looking at in-service aircraft. Obviously, we were looking at aircraft in design. When you've got an aircraft in service, you've got real data about what's maintenance errors are happening. You've also got maintenance manuals that you can read and actually interrogate in more detail. But more importantly, you can involve maintenance engineers that are really doing the work. So that's really the major difference in what we're doing.
Thanks. Hazel, question to you. So you were involved in the work that was performed in, I guess it was November of last year, initially, with Airbus. What were your impressions and hopes in terms of what they were trying to accomplish on the 225?
Well, historically, maintenance error has typically been managed by good human factors in the hangar. And that's very good at pulling down the general error rate, but what it will never do is reduce it to zero. And when we're looking at these really safety critical maintenance tasks, that's really the hope that we can get zero. So this method really complements it by using the design process to pluck out those really safety critical tasks for a bit of extra attention and extra study, and looking at how we might put extra protection around them, and if necessary, actual prevention, parts that just won't fit the wrong way or leads that can't be cross-connected because the terminals are different. And so what this allowed us to do is use the real experience of engineers who are doing this every day, maintaining these aircraft, and feed that experience into getting the right protections around the right parts in a really focused and targeted way. And I think that the engineers themselves quite appreciated the opportunity to sit down with the design engineers, see the component and the task from both sides at once, and really feed their experience, their knowledge, and their expertise into getting the right protection for the context they work in.
And so how do you elaborate on that last point, the engineer engagement? Why is that important?
Well, the engineers, when they first arrived, were very polite, but I think a little bit skeptical. You could almost see them thinking, oh, not more human factors, not more consultants, they think they know their job better than I do. But once we'd worked through the process and they'd seen the value of it, they'd seen how this is actually going to contribute to what they're doing, they became very engaged and were saying that actually this is the most practical thing that they've seen that's likely to really advance safety for them. So I think it was a win-win really, both for the design engineers and the maintenance engineers who went from polite to really quite enthusiastic and were encouraging their colleagues to get involved.
All right, so the history is we had the 225, this exercise that we all participated in the November-December timeframe. Subsequent to that, you and Simon and Scott published the article, yeah? Can you talk about some of the feedback that you've got? Because I thought that was particularly interesting and you shared it.
Okay, so this was an article that was in Aerospace magazine, so quite a few of my friends and colleagues around the place saw it. And the most common reaction was, well, that makes sense, but surely we do this already. And that, to me, was quite a good bit of validation, because it meant that it was ringing to them like good common sense. And the other thing that really came out from people was, great, at last we've got the people who do the job every day feeding into finding the right solution. So there's some quite nice feedback, both from design and maintenance engineers, in fact.
So George, back to you. So essentially what you did.
So to illustrate this process, what we have done on the 225 is that first we have identified all the critical components and all the maintenance tasks linked to these critical components. We have reviewed this list inside Airbus Helicopter with our tech rep, with our instructors, and through a set of questions we have assessed for each task the criticality of the task regarding human factors. In a second step, we have worked, thanks to HeliOffshore, with HeliOne, And we have reviewed the same list of tasks with experienced engineers and less experienced engineers in HeliOne. And they have highlighted another number of tasks. Some and most of them were common with the one highlighted inside Airbus, but some were new, different. So the first conclusion is that we think that the OEM is not able to perform the full analysis by itself because the operator point of view is very important. Sometimes the OEM think that the procedure is obvious, and it is not the case. So that is our first learning. What we would like to do is to extend this review with another operator to strengthen our list of critical maintenance tasks. And what we have already started inside the factory on 225 is to review the first task where the documentation has been highlighted as an issue. So we have had an aircraft during 1 month. We have reviewed 15 maintenance tasks, and we have already some very simple modification to perform on the documentation to avoid maintenance mistakes. To give you an example, sometime in the documentation you have to look the instruction, then they ask you to go back to a figure, so the operator is going back to the figure, but after he has to go back to the instruction. But most of them, they stay on the figure, try to remember what they have read before, and sometimes they don't do perfectly the instruction. So the simple modification is to put the figure on the same page as the instruction. So we are in this process. Next step will be to extend this process to the 175. That we will do.
Francesca, Leonardo is a member of HeliOffshore, and you heard about this. And as the manager of system reliability, what's piqued your interest so far?
So for Leonardo, the point is that we do something during our design phases to take into account also the possibility that maintenance error can occur or a maintenance damage can occur, and this can cause a failure mode that we are analyzing. However, we have reviewed with the human hazard analysis, the fact that even if we have some compensating provision, if you want, or countermeasure in place, also they can fail because a human factor have to take into account. So the point is that for us now is important to understand if we can review our process in order to verify where, if we can improve it in order to reduce as soon as possible the risk associated to the human factor when we're talking about the criticality of the consequence of the human error during maintenance.
So, given that your interest has been piqued, how do you want to proceed?
Now we started with the identification of a list of critical maintenance tasks from 139. So we have considered the most critical one task related to critical parts and critical installation that we have in our helicopter. So we started to define the list and to define the first prioritization inside the company, so with our tech rep and maintenance engineer.
Right, so I know these are rigged questions, but so what's Leonardo's ask of HeliOffshore?
For sure, the possibility that starting from the list, the prioritization, now we have to do the workshops with the operator, because it is important to understand the criticality that there are in the field when the maintainer performs the task. And so we have to have an organization of these workshops with our operator and support us in the management of these workshops. And the second point is the future, so the results that can we have from this kind of analysis, because the result can be different. They can highlight some needed to update documentation and so on, or also to highlight the possibility to improve our design. So it is important to, in case of a design change, in particular, to understand how can we proceed together, to have a commitment in the eventual implementation of the design, if needed.
Thank you. So George, I know that you, at Airbus, you've done a lot, but you also have an ask, perhaps a little bit different, of HeliOffshore.
Yes, as explained before, while working with Airbus fixed wings, we have noted that they have an agreement with 3 airlines, and these airlines are sending to Airbus under an agreement, confidential agreement, all the maintenance mistakes they have observed during performing the maintenance, all the possible maintenance mistakes they have observed. So Airbus is taking this data and is studying safety barrier to prevent reoccurrence. So it means that Airbus fixed wings is able to catch part of the mistakes before they are transformed in incidents. So our request to HeliOffshore is if HeliOffshore community agree to send this data, maybe anonymous, but Airbus will be happy to study this data and to proactively change the documentation or change the design or change the process if we are convinced that there is something to do to avoid a recurring mistake.
Okay, I think that's a great point. Simon, any requests from yourself of what you've seen and experienced so far?
If I can't be too greedy, I want 4. Actually, my focus is first of all on getting design organizations involved. And I say design organizations very specifically because this can move beyond OEM. This is about engine suppliers, it's about equipment suppliers. Anyone can take part in this process to actually identify errors. And so it's really to encourage you all to get involved in this process. The second point is the operators, as we've said, operators to get involved in the workshops we already have planned, but will be extending to other aircraft types. And really, just picking up on George's point, the reason that the Airbus fixed wing, and I'll talk more about the process in a moment, but the way we made it more efficient and effective was to drive it from error data. So we can offer to the analyst what is the most frequent error on that ATA chapter or whatever the point is. So we can really focus our analysis during the process. And I think the final point, which is really we have an opportunity with this group of people that we didn't have in fixed wing, and the opportunity is to really drive this into a standard. We can write something that is cross-organization, and it's really a request for your involvement in writing that standard. The process has started, but it's really, we'd like everyone to get involved to make sure that we really solve this problem and make a difference.
Hazel, any asks from your point of view?
Really just to elaborate on what Simon has said, and to be willing to give it a fair chance, given that it's already demonstrated some worth in fixed wing, to be willing to at least give it a fair trial, as it were. And what that means is, firstly, to please get involved, and secondly, please to be willing to involve the right people. Sometimes I've been in an office where we send who we can spare rather than who are actually the right people to come. So please give it a fair trial. Send the people who are really the guys who do the job and the people who are really involved in the process, so that we give it the best chance and it may reward us with a step improvement.
Thank you. If I could ask you to help me thank the panel for their Q&A today.